Hello everyone and welcome back to the channel. In this video, I show you how I do a quick triage analysis of a malware. The malware that we are analyzing is Racoon Stealer V2 or Record Breaker. Even though this is a quick triage analysis video, I have shown some IDA scripts which I wrote to speed up the analysis. Let me know if you would like me to do a detailed video on IDA scripting. If you are interested in learning malware analysis, where I share how I analyze live malware samples, please check out my course. I have shared the link to the course as well as the link to the malware and the IDA scripts in the description below. With that, let's dive into the analysis. So here I am in my virtual machine. I have this folder of Record Breaker open in front of me, and I have the mals.bin file, which is actually the malware executable. I will drag and drop this on IDA Pro 8. Load the resources, press OK. Next, I will produce the C file for this malware to ensure that IDA decompiles the malware fully. Once the analysis is complete, let us review the plan. So in this video, we are going to analyze the function which dynamically imports the DLLs and the APIs. Then we will go over the string decryption function. I will show you some of the IDA scripts that I have created to resolve the strings and the import address table. Then we will look at the resolved strings and functions. After that, we'll review some of the C2 communication that the malware is doing. Then I will show you a couple of my favorite techniques to quickly analyze malware. Then we will look at selective stealing capability of the malware. And lastly, we will look at how the malware can load the secondary stage as well. I will press F5 here, open the sudo code and bring it side by side with the disassembly of the code. Make sure both these windows are synced together. I will reduce the size of the functions window and increase the size of the Hexrace decompiler window. Let's start going down. We look at the first function and we quickly see that this is the function where the APIs and the DLLs are being dynamically loaded. The DLLs are being dynamically loaded here and the APIs are being resolved here. All right. So let's rename this function to, I am pressing N for rename and then write the name. Resolve APIs. And after I rename something, I press F5 again just to make sure that the name is propagated everywhere. Go back. I'm pressing escape to go back. Now we go to the next function. In the next function, we see a couple of functions. This is the first function that we are going to analyze, and this is the second function that we will analyze. We see some kind of a cryptic string being sent into this function. Now, if we go down further and look at these calls, we see equal sign here and two equal signs here, which gives me an indication that these might be base64 strings. So this is our first hypothesis, that this is a base64 string. And this might be a function which is resolving this or decoding this base64 string. So that's fine. We can go into this function, but we see that there are some dynamically resolved API calls and we cannot make sense of them right now. So let's go back. Let's look at our second function call where the output from this function is being sent. So in this call, we see something which looks like an RC4 decoding function, right? We see that this is an S box here. Then we see something else as well, that this string, which looks like a key, is being passed in the last parameter. And this last parameter A4 is being used in this modulus line as well. So this looks like an RC4 decode function. This looks like a base64 decoding function. So let's now confirm our hypothesis. Let's take this value, copy this. I will open up CyberChef, put the input here. I'll say from base64. And then I will add RC4 here. And for RC4, I'll take this key. Control C, Control V. And we have something which looks like a legitimate string, TLGRM or telegram underscore. Let's take another string, possibly a longer string this time. Control C. This is another legitimate string. So our hypothesis is now confirmed. This is a base64 decode function. And this is an RC4 decode function. Now that we have an understanding of how the strings are being decrypted, I have a couple of scripts which can ease the work of decrypting all these strings for us. Let's take a look at those scripts as well. I'll minimize this, go to the scripts folder, open the terminal, and open this folder in Visual Studio Code. The first script that we are going to execute is going to be decoding the strings. And I will execute part of this code and then I will explain what is actually going on here. So I'll take this code, I'll put it here, and this is the output that we get. Now let me explain the script along with this output. We see the first string that we have here in base64 hex is 404048. We go up, we see 404048, which is the base64 decoding call. And the next thing that we have is 40405F, which is this one, or the corresponding RC4 call. Okay. So let's keep that in mind. And now I will explain what the initial part of the script is doing. We have the function addresses for the base64 decode function and the RC4 decode function. Let's verify these. I'll double click on this decode base64, press F5 to make sure that the name is taken up, press space, and the function address is 401806. This is here, 401806. Go back, RC4 decode, 408746. 408746. So we have those identified properly in the script. Now we have this call where both these addresses are being passed. Let's look at this function. And this function is running a loop for all references to this base64 address. So all references means essentially a call to the xrefs method. So I'm pressing X here, and we see all the calls that are being made here to this function decode base64 are being picked up here. For each and every call, we want to get the corresponding RC4 call location. So for this address, this is the RC4 call location. For this address, this one is there. For this address, this one is there. Okay, so that is the list that we actually printed here. So we have the base64 decode function and we have the RC4 function. Okay, once we get that list, we send it back in the base64 xrefs list. Next, we have another loop that for each item in the base64 xrefs list, we want the B64 item and we want to get the fast call argument number 1 for this call. So this is a fast call. This is a fast call and I want to get the first argument here, right? The first argument is actually the string. So this is the method that I use for this. Once I get the string address, I will get the actual string by calling this method, get value at address. Next up, I want to get the RC4 key. For that, I will take out the address of the corresponding RC4 function. So for this function, the corresponding RC4 function is this one. And this is actually this call, which means that the parameters for this call are being passed in tandem, some on the registers and some on the stack. So if we go back, we will see that the first argument is going to be passed in ECX register here, and the rest of the arguments are being passed on the stack. 1, 2, and 3, EX, ECX, and EDI. For fast call, both the arguments are passed in the registers. So here we have ECX and EDX. All right. So here in this case, for this function, if we treat this like a normal function, this will be the third argument which is pushed on the stack. That is why we are using this get stack argument number 3 for this call. So now we have the RC4 key address, and then we can extract the string and the keys here. And after that, it's very, very simple. We decode the base64 string, and then we use this RC4 key to decrypt the string as well. Now let's run this script all together and see what happens. Now we see that the script has commented the places where the strings are being decrypted with the decrypted string. We can see all these values here. Okay. Now the second script that we are going to run is actually going to be resolving the APIs. Let me first rename this to mw_decrypt strings. And now let's go and look at the resolve APIs function and look at the script as well. If you look at this script, we have this address, which is the address of the get proc address 0. This one, 40E0D8. This one. What we are doing is that for each reference to this call, I will pick up this string and assign it in this D word. And I will also add a comment here. All right. So this is basically the gist of this whole script. So let me Control A, Control C. I have also uploaded these scripts on GitHub. So you can also take benefit from this work that I've done. All right. So now that we have all the variables renamed properly, We can look at the xrefs to get proc address, and we can also see all the comments here, which means that if we see any interesting call here, we can directly pivot to that call. All right. Now that we have done the analysis of the function, which dynamically imports the DLLs and the APIs, we have also analyzed the string decryption function. We have looked at the IDA scripts to resolve the strings and the import address table. And we have also looked at some of the strings and functions. Let me show you one more detail related to the string decryption. I'll go back. Go here to the string decryption function. We go a bit down and we see that some of the strings, like this string here, is being passed to another function and it is being assigned another D word. If we go inside this function, we see that this is a call to multi-byte to white char. So I will say here that MW underscore multi-byte to white char. So this is basically converting the string that is sent here from ASCII to wide. So we'll see here that Telegram string will be converted to a wide string, which is also going to be again Telegram. All right, so that's fine. This is something that we'll have to keep a note of, and we'll have to refer back to different strings at different scenarios of our analysis. Next up, we are going to look at the C2 communication. We go back to our start function and we see some more base64 strings here. Firstly, let's go to this function. If we go to this function, we see that this function is looking for the space character. The str function is a function which is looking for a string inside a string. So in this case, it is looking for the space character inside v2, which is the string that is being passed to it. All right. So v2 is equal to this, and this is the argument that is being passed to it. So it is looking for the strings, and it is basically deleting those strings, right? So we see that in this specific case, we have a lot of space here. So it will be deleted and the output will be assigned into v0. From there, this output will be sent to this function, which we know already, we have labeled it before. It is decoding the base64 input that is being provided to it. And from here, the data is being passed to this function, which we have labeled before as well, which is decoding RC4. So let's see that in action. Let's take the string, put it in CyberChef. We'll take this key. We'll put this in CyberChef as well. And we see the C2 details. We can label this properly, that this is in fact the C2 details. That's fine. And we can see some other empty strings here which are being resolved. I think this is just in case the malware authors want to add further C2s or further configurations to this malware. Let us also rename this function to MW underscore remove spaces. All right, so that's fine. Okay. Next up, we are going to look at C2 communication. Now, if we start going down after all the strings have been resolved, we see the first function call that we have here is get user default local name, which is going to get the local name of the operating system installed. Here we also see that this is being compared to this string, which is actually RU. So sometimes what happens is that Russian threat actors will write code to ensure that that malware or that code does not execute in their own country. So which is why they check the locale of the system before they start executing the main functionality on the system. In this case, we see a check here, but we don't see any action being taken. So that's fine. We can move on. Next up, we have a mutex being opened. And if the mutex is opened, the process now exits. This is in case the malware is already executing on the system. A second copy will not be executed. All right. And if the open mutex fails, we create a mutex to make sure that any subsequent executions of the same process are blocked. We have another function call here. This function call is used to extract the token related information from the malware. So we'll rename this to get token information. After the token information is extracted and assigned into this SID or the SID of the process or the user of the process is being compared to this. This is the SID for the system user. And if that is the case, the relevant response is being returned back. And if this is executing as a system user, this function will also execute, and this function is getting the list of all the processes which are executing on the system. So let's rename this to mw_get task list. All right, we keep on going down. We see some more strings that we saw. I think these are wide char strings which are being assigned to some other values. We look at this. This looks like some kind of a string formatting function. So I'll rename this to string formatting. Go back. This function is opening up the cryptography registry, and then it is looking for this key. Let's look at the value of this string. We look at the xrefs, press X here, go to our string resolution function, and we see that this is actually the machine GUID string. I'll press N here, rename this to machine GUID, and then say machine GUID_W, just to indicate that this is a white car. And we see that here we get the label properly. We can rename this function to mw_get machine GUID. So the operation that is being performed here, that here we are getting the machine GUID, here we are getting the username. Before we had gotten the token information, the task list, and the locale. These are all details which are fetched by malware as part of a process called fingerprinting a host. Now, why does a malware want to fingerprint a host? The first reason is to get an accurate count of the unique number of infected systems. So the details will be sent back to the C2, and the C2 will now know that these are the unique GUIDs that have been infected with this malware. Second thing is that sometimes droppers have a contract that they will be paid per infection. So this is another way for them to earn money. The third one is that they want to ensure that they don't get or keep garbage data. If we have already infected a system and we have already received the data from the system, there is no use of getting the data again and again. All right. So that is why the malwares usually do a fingerprinting on the system and send it to the C2, and the C2 can then reply with further action that is required to be performed by the malware. So here we have the malware fetching this username of the system. We have a couple of string copy operations, and this looks like a string formatting function as well. In fact, this looks like a string comparison function. And we see a lot of these string comparison functions. If we go down, we have this call here. And this call looks like it is related to C2 communication. All right. So in this C2 communication, we can see that there is an internet read file operation. In the read file operation, this parameter is the reply from the C2. So var underscore buffer. And after some manipulation of this data, the data is being returned in the v28 variable, which is now being assigned to v25. So we can say received data. So the next call is this one. In this call, the call to sh get folder path w is being executed. This is an API call which is used to fetch a special folder path, and the special folder for which the path has to be retrieved is passed as an enum here. If we go here, I can say use standard symbolic constant, and we can say csidl local app data. All right, that's fine. And after I've done that, I will press F5 here. We can say mw underscore get app data folder. So this is basically some preparation being done by the malware to I think copy the secondary payload onto the system. If we go here, we see that there is a check. If received data is there, then this continuation will take place, continuation of execution. Let me quickly look at this function. This function looks like it is looking for the string libs. And after that, we see what looks like further C2 communication happening here. And then there is a write file. So I think what is happening here is that there are some further libraries or files that are being dropped by the malware on the system. And this is again based on the C2 communication which is happening. I can rename this function to mw underscore load DLLs. All right, that's fine. So I think the C2 analysis is done. Let us move on to my next technique, which is API pivoting. So let's go back to our start function. The start function, I'll press F5, make sure that things are synchronized again. I'll go to resolve APIs and I'll press X on the get proc address, and I have this whole slew of API calls that are being resolved. Let's take a simple example here of get DC, which is this one. I'll press X for xrefs. It is most probably being converted, or it is being called directly here, which means here the malware is trying to fetch the domain controller related information for the system. And if you look here further, it is trying to further steal some data from the system. It is trying to get the get desktop window, and it is loading some further DLLs here as well. Looks like some graphical information is being fetched. Anyways, so quickly we now understand how I use API pivoting. Now let's look at strings pivoting. Let's go back to our strings resolution function. If I go here, I can pick out any of the strings, but let's try to see if there are any interesting strings here. Logins.json, token, product name. So this string looks interesting. Let's look at this string, the references to this one. Wallets is being assigned to this, and mw underscore wallets underscore w. In fact, let me remove the mw, and n and x here. Let's look here, and we see a string compare with the wallets, and we see the wallet.dat file being fetched here. It is looking for the files on the system. This is basically an iterative loop to look for files on the system. All right, so that's fine. This function is related to mw underscore steal wallet information. And similarly, we can look at other function executions as well. So now we've looked at all these things. Obviously, this is an extensive malware, so it's not very easy for us to analyze this malware in a half an hour or 1 hour video. This will require multiple parts to go through each and every method and try to understand what the malware is doing in detail. I'm just trying to pass on the steps I use to quickly look at a malware and trying to understand the functionality of the malware. So next step that we are going to look at is selective stealing capability based on the C2 request. And we are going to go back and look at this string, the Telegram string. Let me rename this to this and say W. Let's look at the xrefs for this one. And we see here quickly that this is another string comparison taking place here, and if the string exists, then this function will execute here, which is going to obviously steal some Telegram related details from the system, right? So rename this steal Telegram info. Okay, so generally the understanding of this malware is that every time there is C2 communication, the C2 communication is matched with some kind of a keyword. And if that keyword exists in the reply which has been sent by the C2, then some relevant action is being performed by the malware. All right, so that's fine. So now we have an understanding of the selective stealing capability as well. Now, finally, let's look at how this malware executes the secondary stage. Now, this is going to be a longer part of this video. If we look for a certain keyword in the strings, for example, if I'm looking for the keyword LDR, LDR underscore, this one, LDR underscore is being assigned here as well. So this is LDR_W. We look for the XRES for this. And here we have another function where the C2 communication is being passed here in this variable, and we're looking for the string LDR_ in this. If there is a match, then we continue here execution. We see this function is being called. This is a string copy function, MW_ string copy. So details will be populated here. Let's keep on going down and let's look for a function where we see some kind of C2 communication taking place, because this is going to be a function where the secondary payload is downloaded. This is the function call, and we see that we are looking for // in the reply that was sent earlier by the C2. And after that, we are extracting some information from the message that was sent to us. And from there, we are reading something. We are reading a file here from a URL. And then we are firstly creating a file, and then we are reading a file here as well. Okay. The URL that is being opened is, I think, this one. Let's look at the internet open URL W. The second parameter is the URL. This call is being made here. I can rename this to, this is the URL in MW_S2, which is the second stage URL. The second stage URL is being passed here. And let's just say that MW_second stage. If we start going back, we see that this is actually the URL which is being sent. If we click on this, we will see that there might be certain locations where this parameter is being set. All right. And this is basically happening here. I think this is the place where this parameter is being set. And I think the data that is being used to create this URL is V14. And if we keep on going up, we'll see that the V14 would be something that is extracted from the initial C2 communication that takes place, if that C2 communication has the word LDR_ present in it. All right. So I think this is a very good point for us to end this video. I have tried to show you quickly in a summarized manner how I do the analysis of a malware sample. In this case, we had the Racoon or the record breaker malware. Thank you very much for your time, and I hope to see you in the next video.